So again, good morning. This is track 3. And I'm very happy to introduce François. I saw an early version, or say a predecessor of this talk at another conference last year. And after that, I approached him. I was like, hey, this is very cool stuff. And I think there will be lots of interest for that at Troopers. So please submit. And he did, and he might have hoped to be in track 1. But at times, we take talks with a somewhat offensive angle and put them in track 3, as we think they are particularly suited for an audience from large organizations. And I think this one is super interesting. I'm very happy you came to Heidelberg, François. Up to you.
Thank you. All right. Good morning, troopers. I'm François Proux, VP of Security Research at Boost Security, a startup in Montreal, Canada. And for the past 4 years or so, I've been speaking at several conferences internationally to warn people that CI/CD pipelines are vulnerable. And in fact, we've made hundreds, if not thousands, of disclosures to small and large open source projects over those years. And in fact, our own team created several open source projects of our own, including a build pipeline static code analysis scanner that we called Poutine. We're from Quebec. And also documented the living off the pipeline techniques to help defenders. But in the meantime, the threat actors were clearly paying attention, which means that now I'm done just talking about it, and I want you guys to have your own oh shit moment, the kind that I had when I first exploited a pipeline in a major open source project. In late 2024, I found a smoking gun. A threat actor on breach forums, a well-known cybercrime forum, dropped a 0-day against a very popular Python machine learning library called Ultralytics, and literally cited our own tools and research as the way that they got to compromise this machine learning library. So they basically used our defensive manuals as their offensive playbook. And then in the fall of 2025, it got crazy. We had several worms spreading malware, mostly across the NPM and PyPy ecosystems. And fast forward to a couple months ago, in March 2026, and threat actor groups such as Team PCP, but not just, are having way too much fun creating chaos. And if you look at the escalation curve behind me, you can exactly see how fast this threat is growing and how the threat actors are actually picking up on those techniques. We know for sure that they actually used the exact vulnerability that we had disclosed, but it was not patched, to poison a very popular security tool called Trivy, which I'm pretty sure many of you are actually using in your enterprise to scan for SBOM and things like that. So Trivy is an open source project, very much used, and it was compromised and backdoored with an InfoStealer malware. Then, and using the hundreds of build pipeline secrets that they had exfiltrated thanks to that poisoned version of Trivy, they then went on to compromise dozens of other packages and started blackmailing large corporations such as like Fortune 500s. So this is not just theoretical anymore, it's happening right now. Maybe some of you had to do incident response even. And as you can see, it's not slowing down. Before I go too far, I want to make sure everyone in the audience is on the same page. So we'll do a 2-minute crash course on software supply chain security. And I'm going to be using the SLSA framework. It's pronounced SALSA. So on the left-hand side, you have what they call the producer. But really, we should just say it's the developer writing code, typically from their laptop, using Git to commit and push code to a shared repo, typically GitHub or GitLab, right? And most likely then they will open a pull request or a merge request so that colleagues can review the code before it gets merged to the main branch. And the mere fact of opening a pull request very, very often will automatically trigger a build pipeline, CI/CD, to run the tests, linters, and whatnot, right? And often that pipeline will also contain a bunch of secrets, signing keys to push the release version of the package. So, indeed, the CI will typically push the artifact downstream to a registry of some kind. For instance, in the case of open source, it's going to push to NPM, PyPy, or Docker Hub. But in a corporation, it would push typically to a Docker registry so that your Kubernetes cluster can fetch the latest version. And as I said in the past, I think we should really rename CI/CD RCE as a service, because it's much easier to understand, the threat landscape when you picture that in the middle of this pipeline you have RCE as a service. So let's do a quick refresher on the types of vulnerabilities we're actually dealing with here. First, we have the so-called PON request, which is just a pun on pull request, PON request, which is really when a pull request, or a merge request in the case of GitLab, contains files that modify the behavior of the tools already used by the pipeline. So this is why we came up with the term living off the pipeline, because the attacker is simply using the existing tools already used by the pipeline and not adding anything new, but given the configuration file, for instance, it's going to allow them to have remote code execution. Second, we have template injection, those so-called mustache expressions with $sign like that. But it's really just common injection like 1995, nothing new here. And depending on the context where the expression gets interpolated in the template, the payload might actually be different, right? Third, we have bot-mediated confused deputy. It's just a fancy way to say that if the pipeline somehow also trusts a non-human identity, a service account, or something to run high-privilege actions, sometimes, and depending on the authorization logic, there may be ways to bypass that and kind of game the system to get this confused deputy. Finally, we have self-hosted runners that are not ephemeral. If you recall earlier, I renamed CI/CD RCE as a service. If you keep that in mind, because a runner is simply a virtual machine, and if you decide not to use the host runners, the managed runners by the platform, for some reason, maybe you want to self-host because you need a more powerful CPU, a GPU to train some machine learning models or whatever, then you need to keep in mind that you have RCE as a service and harden everything accordingly. So it's important to agree on the threat model we're talking about today. In this demo that I'll be doing, in fact, I'll show you that sometimes those two threat models can blend in and overlap and transition from open source to enterprise takeover kind of scenario. But typically, the most common one that we see and the threat actors, as I discussed, have been using as initial access vector is the open source software compromise scenario, where the threat actor will be just forking a public repo on GitHub, for instance, opening a pull request, which will trigger the vulnerable pipeline, and then they will go about their day to compromise the package. In the case of enterprise takeover, the threat actor will have the initial access by maybe phishing, info stealer malware that was pushed in some other way. They will steal some credentials, maybe SSH private key, some GitHub personal access token, and then they will impersonate the employee that has maybe only read access to private repos that might already be useful just as intellectual property theft, if the user has write access to the repo, or admin access. So depending on that, they would have different techniques available, but let's just say they have only read access to, they might be able still to open GitHub issues or bug tracker kind of, and that might trigger the build pipeline as in reaction. As for pushing code, even though they can just push code to, not directly to the main branch, that would still trigger the build pipeline to run the tests. But because they're a privileged user, they actually have access to the repo, that will give more power than an external attacker would. So it's important to keep that in mind. And now I'm really excited to tell you about our brand new tool. It's called SmokeMeat. It's an open source red team post-exploitation framework designed specifically for CI/CD pipelines. It's basically like Metasploit, but for your build infrastructure. We built it to show you the exact blast radius of a compromise before a threat actor like Team PCP would do it for real. And in fact, this tool would not exist, and I would not be here, as Eno said, if not for the fact that I presented last year at Munich Cyber TTP. And after, I talked to Eno, and he challenged me to give more live demo, go in more depth and whatnot. And I thought, well, I'm going to need to script it more. But then I decided, I'm just going to build like a freaking Metasploit for it. So that's what I ended up doing. So this is the architecture of SmokeMeat. It starts with our existing open source tools, the one that I mentioned called Poutine, which has existed for several years now. It's very mature. Many people, corporations like Datadog, Netflix, Meta use it every day to scan build pipelines. You can customize it with your own rules for your own needs internally. But in the SmokeMeat platform, it's used as a library to detect the vulnerabilities, and then SmokeMeat will generate the exploitation payload. We also use the LOTP catalog, the Living After Pipeline catalog that we've created over the years. There are many people that contribute in the open source project to it, including big banks in Germany and Netherlands that I know that made great contributions to this catalog over the years. So basically, the SmokeMeat platform is composed in 3 main components. You have the Red Team Operator Terminal UI, which lets you operate, the testing. You have the C2 team server, so it's meant to be used in a red team scenario where you have multiple people collaborating. And you have basically the implant, the one that will be injected in the CI/CD to do post-exploitation techniques. And you have a bunch of side things which you'll see in a moment. So in order to allow people to experiment safely with that, I built a capture the flag environment, which is hosted on GitHub. You can find it at github.com/huli, and that will be the object of the live demo. So basically, this Huli environment has a first kind of track. The common foothold is on the public repo only. And once you've achieved some exploitation of the public repo, you can pivot to private repos and later all the way down to cloud compromise. As you'll see that both on hosted runners and self-hosted runners. So let me leave the slide now, and everything will be live. So crossing fingers that GitHub will not break, on me. But I tested earlier. Okay. All right. Okay. So first, we're going to look at the GitHub repo for SmokeMeat. If you scroll down, you will see the README, which contains quick start instructions. You can just copy the instructions and switch to the terminal. The instructions are basically, hopefully it's going to be zoomed in enough, I can zoom in more, but it just git clones, switches to that repo, and uses the quick start mode part of the makefile. You can, obviously this is just, to simplify things, it all runs on your machine, Dockerized using Docker Compose. And it's going to start a tunnel to connect back to the container and the environment for the C2 callback. Obviously, in a red team scenario, enterprise, you would have the team servers set up on a virtual machine, and you would not be using Cloudflare. But this is very easy to set up in just a couple seconds. So at this stage, it's going to indeed skip the various first steps, which you would do if you were doing the fancy configuration. And here it's just asking for some kind of credential. So at this stage, the different threat models that I mentioned are important to keep in mind. Do you want to simulate an adversary that is just public access to public repos, or someone that already has some kind of access to the enterprise repos already, right? So maybe you want to give it the token of an intern, maybe. Okay, but we'll give just a public repo access. Trust me. So at this stage, you want to specify your target. So we'll specify the organization, or it could be a single repo in case you have a very large organization. I've tested with GitHub organizations where there's 10,000 public repos, and it takes about 5 minutes to scan. So But here we just have a couple, so we'll do a huli. It will discover the Wi-Fi. That's not good. Let's see. All right, we're doing it. It's live. Okay, so let's see if I will need to set the. Let's see. We'll try it again, maybe. Okay, sorry. Let's try again. Hope it was not just the token I copy pasted was truncated. Check. Let's see. Okay, let's try again. Okay. Yes, okay. Okay, good. We're back on track. Hopefully you can see if I'm zooming in. You see everything? Okay, good. So as you can see, it has scanned the organization and discovered public repos at this stage. There's only one public repo that has something interesting. So it will index the workflows, the jobs, and the vulnerabilities it discovered in each of them. Obviously, it's capture the flags. It has tons of vulnerabilities of all kinds. And you can navigate using the arrow keys, the function keys to kind of toggle between the different sections. So on the left-hand side, you have the index, the graph database that you'll see in a moment. And then you have the menu of exploitable vulnerabilities that it has high confidence that it can automatically exploit. So it will also use a ranking algorithm based on the secrets it has statically discovered. So in this case, for instance, there are multiple secrets. And it will rank this one, the huli analyzer, right at the top because of that. So that's this. And then you can hit tab and you type some commands right here. You have tab completion and whatnot. So I can show you to the graph view. You press G, you go into the browser, and you can visualize that you have one public repo, bunch of workflows, and the jobs and eventually secrets. At this stage, just static analysis, no exploitation, right? So this is purely safe. You can do that against pretty much anything. It's just normal GitHub usage. You can switch to a source viewer, which will just, again, confirm we only have visibility over public repos at this stage. And it kind of gives you the visibility into which authentication you're using for that, just public at this moment. Okay. Let me go back to the tool. Where is it? Okay. Okay. Cool. So we're just gonna dive right in. In fact, so I mentioned that we're gonna exploit the first vulnerability, the huli analyzer. So I can press just one. It opens a payload wizard to configure the exploit. But we're going to actually statically analyze the vulnerability before we do that. So I'm going to switch right here and find the workflow that we want to analyze. So this is even better than just github.com because there's an audit, like a workflow audit mode, where you can kind of see the source to sink tracing, see where the workflows that have some secrets being used, and basically the vulnerability is on line 32 here, where there's just a stupid injection like it's 1990s, but it's very common. So there you go. So that's going to be our target because it has a high privileged private key right here that will be very useful for pivoting. Okay. You notice also it has this gate. It auto-prepends the @hulibot analyze. And that's because it statically detected that there's a condition that would prevent execution of the workflow if not for adding this bot command. Because this is a comment-triggered workflow where you could comment on a pull request or a bug tracking issue. and the smoked meat logic will detect that and resolve the Boolean condition automatically. Okay, so it can create the issue and add the comment automatically, or you specify an existing issue or a pull request you want to comment on. Otherwise, you can just copy-paste the payload, which will still connect back to the C2 automatically. So there are some scenarios where you might need, to social engineer the maintainer before you copy-paste the payload, things like that. So it's very flexible. But for here, happy path, we'll just do it like that. Then there are extra configuration. We're not going to touch those for this, but later it will come in handy. So if you press D, you can cycle through dwell time. By default, it will just push the implant, dump the memory, and get all the secrets. Otherwise, you can kind of dwell for a couple seconds, couple minutes, and that allows you to run some custom commands remotely before the VM is torn down. Okay, so let's just do the default configuration. Then you're in waiting mode. You can press O to navigate to the payload that was injected as the comment. You see it's a very simple subshell. It already executed, so the workflow is running, and in just a couple seconds, typically, there we go, 20 seconds or so, we are in post-exploit phase. So the exploitation is already done, and it kind of dumped all the memory with the secrets right here, so you can navigate. And if you notice, I will just go back to the tool. Okay, so we just see public repos, right? And later you will notice that we can, let me do that right now, in fact, so it'll be fun. So you can highlight the GitHub app private key and press P to pivot. So that will use the private key to exchange a new access token, fresh access token, and automatically reanalyze to discover the private repos. And in fact, the graph has already updated. So now you have visibility over not just public repos, but private repos. And the new workflows and the new vulnerabilities have been indexed already. Switching back to the source viewer will prove you that you have visibility over that. And indeed, now you're impersonating a service account to give you visibility over that. Okay, so that's the first stage. So that's that. And I'm going to switch back to the slides so that we can kind of dig into what we just saw. So we started with the recon phase, discovering the vulnerabilities, exploiting, and then post-exploit. Okay. So we exploited just a simple injection vulnerability here. It was a bash context, but there are scenarios where it's JavaScript context, so the payload will change. Smoke Meat will automatically craft the payload accordingly, depending on the sink. So if it's, or the source and the sink, if it's a pull request title, a comment, or a Git branch name, all that will add some extra conditions to the way the payload needs to be crafted. We looked at the vulnerability itself. It was very simple. As I mentioned, Poutine is used as a library to detect the vulnerabilities. You can see the actual rule that triggered this detection, and you could clone it, customize it to your own liking for your own enterprise needs. Maybe you want to detect something very specific to your policy. So it's very flexible for that. And then finally, the actual injection, payload crafting also supports the PON request scenario based on the LOTP catalog, where we index the different tools that can be exploited. So going a bit more depth, the one that we exploited was very similar to this trivial bash context. So to make it reliable, typically, in most cases, it will be enough to just do a subshell that will work in most cases, except if it's like a single quote wrapping the subshell. And it will automatically discover that and break out of the context where it gets injected. Obviously, the evil.com gets automatically populated with your C2 through the tunnel. And in other contexts, such as a Git branch name injection, there are more constraints, right? So Git branch name, you cannot have white spaces, and it's limited to about 250 characters. So we use a different kind of encoding, with the subshell and using IFS, as well as base64 to encode the actual URL that contains the stager ID, the unique ID to call back and get the ephemeral payload. But that's very reliable in almost all cases where you inject through the Git branch name. Very common scenarios would be with where you have like npm install part of the pipeline. So in this case, it would craft, like would just overwrite the package JSON and put a pre-install command with the callback to the C2 in this case. So this is a link to the LOTP catalog. So if you want to see the other scenarios that are supported by npm, if this one would not work for some reason, but it's pretty reliable. So I can even share a technique that I never disclosed publicly before. And to my knowledge, I don't even know that threat actors are yet using it. So if I see people using it in the next few weeks, I will know that they were in the audience. But so basically, this is a more advanced technique to be a bit more stealthy and trying to evade like EDR that would be XDR looking at the pipeline telemetry. Imagine a scenario where you have this Git branch name injection with the head ref like this, and you want to avoid calling back straight to the C2 because if you have some telemetry, it might detect that it's phoning back home, right? So the trick is to just use Git itself as the C2 to be under the radar. So how do you do that? Is the Git branch name, again, because it's very constrained in length, you cannot put like a very complex payload. So you're limited quite a bit. So the most compact payload that I found would be to actually use that as a trampoline to put the bigger payload as a Git note. So Git note is a feature of Git that not many people use. So instead of just pushing commits, you put some extra metadata, also part of Git, and that can be up to 100 megabytes. And because it will still be in Git, it will just look like any other Git protocol data. And even more, you can use like a fileless approach using mmfd create to avoid dropping a file in the file system to further evade detection. So here, I'll give you a more advanced example of LOTP. So let's imagine a scenario where you have something that does like a pull request docs preview. So maybe you're contributing to an open source project, you want to modify the documentation, and it will automatically update the preview. So this would look something like that. So that's actually not so far from something I actually discovered in the wild. Obviously, it's a bit crafted to make it more interesting here, but still. So imagine that you have the pull request. It looks like it's using a service account to push to an S3 bucket so you can do the preview. It's going to pull the data from the attacker's pull request, the contributed code, and run Trivy for some reason. And Trivy will be looking for a config file in the current working directory, so the attacker can override the configuration that Trivy will run. If you look at the LOTP catalog, you will see that there is no remote code execution directly through the config file override, but there are a number of primitives, like low-risk primitives, such as reading environment variables and exfiltrating through DNS exfiltration. So there's no like raw HTTP or TCP, but you can still do a DNS kind of record check, and that would allow to exfiltrate privileged or like sensitive environment variables. XSLT proc, processing XSL. The attacker here would control the XSL document in XML, or the XSL, and you'll see that there is also some extra primitives. Okay, and finally at the bottom, you see that it's pushing to an S3 bucket. How can we combine those three tools? So Trivy is going to be looking for the config file, and it's going to allow the attacker to get some sensitive environment variables, and then exfiltrate them through a DNS channel, just like a, like base64, the data through a subdomain. Then the next command will run the XSL that the attacker controls, and it would fetch from a URL to basically get the variable that was exfiltrated right the line before. So it's just a dance between the two and the server side. Then in the XSL, you would use EXSL extensions to write the new primitive to write a file. And you would write to the special file, which has this randomly generated name, the path, extracting the GitHub env file. And that would allow the attacker to write a payload like shell script somewhere and poison any further execution of bash through the bash env like this. So when we reach the run step, we have poisoned any execution of bash at this stage, and even before AWS S3 sync runs, it will run the arbitrary shell script. I showed you that it actually dumps the memory, gets all the secrets in the loot stash. So threat actors that we see in the wild, they use typically this very simple Python script to dump the memory. In SmokeMeat, it's all written in Go, and the module supports its cross-platform Windows, Mac, Linux runner, very efficient. And typically on Windows, it's like 500 milliseconds to dump all the secrets and index them. On Windows, Mac, it might be different, but it's very, very fast and reliable. Okay, so now we'll go back to live demo and do something fun. Okay, so now we've discovered private repos. So we're going to pivot to, trust me, the next one in line is going to be this benchmark bot. And it has this interesting vulnerability right here that's indexed as 2. So benchmark bot in the infrastructure definitions repo. So let's look at it briefly before we exploit it. Okay, so the benchmark bot is, again, a very classic injection, nothing fancy. All right? But if you notice, it doesn't have any secrets, right? So it's like it just has read-only to the repo we already have access. No other secret, no service account. So what can you do with that, right? Well, we're going to use a technique called cache poisoning. So if you press C, it automatically detects that this is a candidate for cache poisoning because it sees that it has the right preconditions, and there's a corresponding victim. So the victim would be another workflow in the same repo that will consume the poison cache. So that will be the deploy workflow, if I recall. Yes. So this one is much more interesting because it has the ID token rights, so OpenID Connect, service account, and but you see that it has no vulnerability. So there's no way to directly directly exploit this workflow. So we need to do it indirectly. So we're going to configure the cache poisoning, and we press R to make sure that we purge the cache. This is just to make it more reliable. And then we set the dwell time, because this is just ephemeral run. We want to have extra time to do what we want with it. So let's say 2 minutes is going to be enough. Okay, so everything is configured correctly. Poison, okay, good. So this will take a bit longer because it's going to synchronize to push the cache and whatnot. So if I press O, yeah, there we go. So this is the private repo that was the injection here. So it triggered this first workflow so that it can poison the cache. So if we look at the cache at this moment, it's currently empty, but in a couple seconds, it should get poisoned. Okay. So we could see that even, because obviously here I have access to the private repos. This is not quite realistic, but you can use the private browser to do the same thing, so you could inspect the actions through the service account that you have access and confirm that the cache has been correctly poisoned. Okay, so here you're back to recon stage, and you can press Shift-I to see the remote implant. So in this case, this is a cache poisoning implant. And we can press N to make sure that the next time the deploy workflow will be triggered. So it could be like running through a normal scenario, but here, to make it easy to demo live, it automatically triggers on a cron job every 15 minutes. And also to make it a bit faster, I can trigger it because the service account I stole before has the ability to just trigger it. So, okay, so we'll set just the next duel. And again, just to confirm, you can see the permissions you have access through this service account, actions right. That's not enough to trigger any vulnerability, but it's enough to just trigger the workflow. So let's see, we can use, in fact, this search thing, deploy, and we'll press X, and dispatch. Okay, so let's go back here, and we can confirm the deploy. So it's currently running, and the poisoned thing is in the post-checkout stage. So when it reaches the setup go cache, it will pull from the cache, and that will override the post-checkout script. All right. So as soon as it reaches that one, so now it's in progress, which means that hopefully, yay, okay. So now you can see at the top right, we have a countdown. I put 2 minutes. So now we have about 2 minutes to do what we want. Okay, so I'm gonna do a command here at the bottom, as you can see, like pivot GCP will send a command to get a fresh access token to Google Cloud. So I'm just gonna open the panel to show you. So what it did, it sent the command to the implant that's still running, the one with the countdown. It discovered, the service account access using OpenID Connect, and then confirmed that this service account has visibility over buckets. So now we can drop into a shell, like Cloud Shell. And this is an ephemeral container, so it's not touching your machine, but it has all the service account that you just got pre-configured. So we'll do a list of the buckets, and this first bucket yeah, it contains a flag, so I'm gonna drop the content of the flag. Yay, we got the flag. Okay. Okay, so that's one bucket, but what about the other buckets? I can list their mere existence, but no. So we're gonna need to go back to another part of the live demo for that one. Okay. So what did we do? Cache poisoning. Well, cache poisoning is a technique that was pioneered by a fellow researcher called Adnan Khan, with whom I collaborate regularly. He created a tool called CacheRact about 2 years ago, and in fact recently got a pretty good juicy bug bounty from Google, and that was the technique he used to compromise the Angular library, and prove that that was necessary to use cache poisoning to poison the release workflow. So you can, in fact, find the article. It will explain, and what I just showed you will resonate quite well, because that's very similar. Instead of accessing a bucket, he proved that he could push a vulnerable version of Angular. Okay, and in fact, recently, like about a month ago, threat actors have been using exactly that technique to poison several NPM packages through the TanStack worm campaign, where the release workflow was using trusted publishing, and if not for that cache poisoning, they would not have been able to do that. Okay. So cache poisoning, that I explained that, and then what about OpenID Connect or OIDC? So OpenID Connect is a best practice that is recommended by most people to avoid having long-lived tokens in your build pipelines. But if you have short-lived tokens that are ephemeral only during the execution of the build pipeline, but you have RCE, well, it's still game over if you can dwell for a couple more seconds, right? So that's what I showed you. There's another great talk by a fellow researcher called Aviad Hahami that used to work at Palo Alto. And it goes into much more details about exploiting OpenID Connect, but through other means that I didn't demo today. Actually, I have a disclosure that I can talk about publicly just as of like a week or two ago. So in April, GitHub made a change to OpenID Connect behavior. Every day I check the GitHub changelog, and I noticed that, this changed. So they were going to migrate from having the subclaim to just having the repo to add the org ID, repo ID. And, I saw that and went on about my day and had a, light bulb moment where I thought, gosh, like, depending on the way that it's set up, there's a waiting period between the time it is effective, this change, where the threat actors can squat, like basically they can typo squat those create repo with that exact ID. And in fact, someone had the same idea at the same time, a couple minutes before me, and typo squatted github.com/AWS with the org ID of AWS. So they were pre-positioning to attack using exactly that. So I disclosed to GitHub the next day, and 1 hour after, it was pulled from production. So they pushed that. It was in production for about 1 day. And 1 month later, they came back with a better mitigation that was not vulnerable. Instead of using a dash, they use an @ sign. So there's an article on our blog that explains this whole story of the disclosure and what we learned about that. Okay, now let's talk about self-hosted runners. Okay, so everything I showed you so far was using hosted, managed, ephemeral runners, right? Those that are provided by GitHub is just a virtual machine that's created just for the length of the job, right? And it's okay because it's trashed. It's a fresh VM when you run, and you can harden it accordingly. You can not put some secrets and whatnot. Okay, but let's say you need self-hosted runners to run. Maybe you need access to something in a VPC that you have. You need those fancy GPUs, right? Okay, so the Huli CTF has a whole extra track using self-hosted runner. So I never demoed that one live, so hopefully it's going to be okay. So, okay, so we will jump to make sure the self-hosted runner is up and running. So, I will just kind of wake it up to make sure it's running. So trust me, it's simply to avoid it like taking too much time after when we do the demo. Okay. Hopefully this should take about 30 seconds or so. And in the meantime, we can look at the workflow we're about to attack. So there's this sync workflow, and there's this deploy. Sorry, I think it's this benchmark, but okay. So the sync workflow, it has a contents read and all that. So it's, the first part is simply about bootstrapping the environment, make sure the self-hosted runner is up and running. And here it's actually using the self-hosted runner. Here you can see runs on self-hosted Linux. And it has access to this other bucket that we were after earlier, we couldn't get to, right? So that's going to be our flag right there. But how do we get to it, right? So there's no vulnerability right here, but there's definitely something juicy. And it's going to be running every couple minutes, or we can trigger it, as we just did, okay? And then right here, though, there is... okay, let me go back. Okay. Yes, okay, sorry. First time I do it live. So what we need at this stage is something we don't yet have in our loot stash. Right now we just have a GitHub app private key, which was enough to get us an access token to get us more privilege. But what about maybe there's something else in this environment that we haven't discovered so far? So we're still targeting the Huli organization, so I can press D on the keyboard or type a special command, deep analyze. What will that do? That it will do not just run Poutine, but run to find secrets. And lo and behold, in this private repo, there is nothing but a README with an SSH private key. In private repos, you can stash your stuff, it's all good. So we press D, and there you go. It found the secret, and now it's in the loot stash right here, private key. It found it in the README. And if I press P, I will validate that private key. I need to make sure I have the benchmark, but there we go. There's a little UI bug here. I'm sorry. We'll need to restart. Should be okay. So I'm going to get a fresh access token. And now I'm going to use the private key and pivot. Okay? Okay. So pivot. There's a. It's not good. Okay, no, whoops, sorry. It worked. So if you notice in the logs, it used the SSH key. Ooh. It used the SSH key, and it enumerated the repos it knows about, even the private repos, and now it confirmed that using this SSH key, we have write access to the infrastructure repo. So that's something we didn't have before. And what we can do is drop into SSH shell, which is going to be another ephemeral container that's pre-configured with the SSH key. And we can, do some git clone just to confirm we can clone, and, we could commit directly to it. But there's an even easier way because it's built in to exploit self-hosted runners. So what we need at this stage is to exploit it. So we're going to find the self-hosted runner. It's indexed as a different type of node in the graph. And if we press X, we have a wizard with something different. And because it sees that we have the ability to push using the SSH key, we can auto-push a workflow to a side branch. And what we'll do is press P to make it persistent. So now we're going to reside in the VM, even past the execution of the job. Okay, so now it's running, and let's see what we have. So if we look at the branches, you'll notice that I tested quite a bit yesterday, and it just pushed a brand new branch, not to the main branch, and it pushed this weird new workflow that didn't exist before, Smoke Meets Self-Hosted, and that was triggered automatically right here. Okay, and once it finishes, get the callback. Yeah, hello. Oh, there we go. So we have a resident foothold in the self-hosted runner going forward. And we can press Shift-I to confirm that we now have other implants, not just in the cache poisoning, but we have that one, okay? And now we can trigger the other workflow, so the sync one. If you recall, I said that there was no vulnerability, but if it gets triggered at some point later, and we have persistence over it, we're going to be able to observe anything and get other secrets. Okay. So the second one, this is the first, the ensure. It's just going to confirm. This is the slow part, I'm sorry, but Okay. So it's queued on the self-hosted runner. There we go. We should be okay. Yes. Okay. If you notice in the chain, the logs here, it actually saw another job that was scheduled on that self-hosted runner, and it automatically grabbed it and detected that it now has some extra, a new shell with no ability to list the buckets. But we discovered the name of the bucket before. Okay, so what was the name of the one that we needed? This one. So this one we couldn't list. I mean, we could list, but now we can list the content of the bucket. Aha, there's a flag. And let's see. No, wait. We need to know what's in the flag. Now you can clap. Okay. Good. Whew. It worked. Okay, so in order to exploit self-hosted runners, you need to live past the job duration. To do that, you need to unset or set to blank the runner tracking ID, which is a variable that tells the runner that this job should, what's the ID. If you don't have that, the process will outlive the duration of the job. But if it's a managed runner, it will still kill the VM. But because this one is long-lived, you will outlive and then observe anything that will be scheduled in the next minutes, hours, days after. In fact, this technique was perfected at scale by, again, Adnan Khan, and he was able to get bug bounty, well, not bug bounty, but he did coordinated disclosure with Intel Corporation about 2 years ago, and got access to CPU schematics using this technique even. So that was pretty big showcase of exploiting self-hosted runners at scale. Okay, so now let me leave you with a final takeaway. If you still think that this doesn't apply to you because you only have private repos, the threat model simply shifts down internally, as you could see, with the different transition between public repo to private repos. It's quite obvious. But if you have this kind of enterprise takeover scenario with phishing or whatever, you might start already on some private side. Maybe you only let your interns file bugs to the bug tracker, but that might actually trigger some workflows. And in all cases, it's still RC as a service, and that might allow the attacker to compromise those vulnerable workflows. If you think that an insider threat is a minor risk, well, think again, because of all the worms that we saw. Some of those worms, more advanced worms, were actually using automated exploitation of CI/CD, even some that were using cache poisoning automatically as part of the worm. So it was able to even pivot all the way down to Google Cloud, AWS, and we saw that as recently as 3 weeks ago. So Smoked Meat lets you simulate all that perfectly. It gives you a chance to shift the threat model by providing the token of someone that has just read-only access or write access to some repos. And basically, to build pipelines that are defensible by design, we have to stop treating them like glue code and start treating them as critical production systems, because that's what they are. Indirectly, they will end up pushing to production, right? And that's why I came up with the term threat model, your YAML, and I, in fact, printed some laptop stickers if you'd be interested, right here. I have some for you guys in the audience. And yeah, so that's really what I want you guys to leave with, and tell everyone that CI/CD is basically like production. It's a gateway to production, and if you don't design accordingly, with this RC as a service, that hot potato you have in your hands, you need to think about that. Okay, so if you are interested in keeping up with our research, we have our blog, labs.boostsecurity.io, where we publish a bunch of articles, the open source tools, poutine, smoked meat, bagels, another one I didn't talk about. The Hooli capture the flag environment is always ready for you to exploit. It worked live. And the living of the pipeline catalog, there's many people that contribute to it regularly. You can look at the GitHub issues. There are many easy, good first issue that are the research has been done. So you can take some of them and finish the documentation. And you can look at our YouTube channel and find a 3-minute video of the live demo. Just that gives a quick recap. And yeah, that's pretty much it. So I'll have maybe a couple minutes for some questions. And thank you.
Thank you so much, Francois. Exactly what I hoped it would be. Live demos worked, great presentation, stayed on time. I mean, that's exactly what you want from an organizer's perspective.
Thank you.
You mentioned it already. I should have done when I did the intro at the conference, where I saw an earlier version of this. Is MCTTP in Munich. It's a cool conference. The organizer, Flo Hansemann, he's also at Troopers. Okay, he seems not to be in the room, but yeah, keep this in mind. Good conference, and many people from ELW will be there. So, besides that shout out, any questions you may have?
All I ask is give some stars on GitHub and tell other folks. It's always good because I want more people to know about this kind of techniques. They're unfortunately very well known by the attackers, apparently, and it's too late. So now everyone needs to catch up.
I have a question over here.
Hi, awesome talk. Thank you very much. My question is this entirely the users, the developers' fault, or would you wish for the platforms to do more to counter that? And what would that be?
Yeah, both. So obviously, it will always be RC as a service. A CI/CD, build pipeline, by nature, you want to run the tests that you just pushed. So what are tests? It's just code. So it will always run new code that was not reviewed. So from that perspective, threat model your YAML. But yes, the platforms, GitHub Actions, GitLab and whatnot, they can do more to remove foot guns and not let you do things that are dangerous, like expose secrets in the context, or at least make it easier for you to know that it's dangerous. And GitHub has done certain things, and they have a roadmap to do more this year. I'm actually working directly with GitHub and doing security review of the new features with them. And I'm quite pleased with what I'm seeing. But it took threat actors like this for them to wake up, unfortunately. So I have some stickers if you're interested.
Thanks, Fox, for listening.
Thank you
Thank you again, Francois.